In this lesson, we're going to look at the volume of 3D shapes, and in particular the prism. Now, before we continue, it's important to understand what a prism is. So in this first example, this is called a triangular prism, because we have a triangle here in the red, and opposite this we will have another triangle that's parallel and is exactly the same size. The mathematical word for that is congruent. If we chop this prism all the way through, you would create more triangles like the red one at the front, exactly the same size and parallel. This makes this called a triangular prism. In this second example, the shape at the front and the back looks the same all the way through and is parallel and congruent as a pentagon. Therefore, this is called a pentagonal prism. And in the last example, we have a hexagon at the top, a hexagon at the bottom, and if we chopped it sideways all the way through, you get more hexagons the same size and parallel. So this is called a hexagonal prism. Now, to work out the volume of these shapes, you basically have to know the area of the red part and multiply it by the length. In the second example, you would need the area of the pentagon and multiply it by the length all the way through. And in the last example, you'd need the area of the hexagon and you would times it by the length, this time up and down the way. So let's look at this with some numbers. Volume equals area of the face times the length. That's the formula for the volume of a prism. In the case below here, we have an area of 40 and the length of 7. So if you multiply these numbers together, you'll get an answer of 280 centimetres cubed. Cubic centimetres, because we're dealing with volume, not area, which would be squared centimetres. If you look at this slightly harder example, we have to calculate the volume of this one-person tent. Now, in this example, we're not given the area of a face, or the face we need, so we have to work it out. So the triangle information we've got on here is the base and the perpendicular height, and the formula to work that out is a half base times height. The base and the height are at right angles to each other, so we can use this formula. This diagonal would not be the perpendicular height, therefore you wouldn't be able to use the formula if you had that, only that information in the base. So if we put the numbers in, the 1.3 is the base, 1.6 is the height, and to multiply by a half, you can either do 1 divided by 2 times 1.3 times 1.6, or you can multiply by 0.5 in the calculators, and it comes out as 1.04 centimetres squared. So now we have the same scenario as before. We know the area of the face, we have the length, we can just use the formula volume equals area of the face times the length. So we take our 1.04 and times it by 2.7 to get our answer of 2.81 centimetres cubed. Now the area of the face can be anything at all. In this case it's a triangle. It could be a circle or a rectangle. It could be a combination of two different shapes. But the idea will be exactly the same. Work out the area of the face or the composite area, get the two areas and add them together, for example, and then times it by the length.